that I will do. Okay, so first of all, I need to explain you like what's your project, okay, and how we are doing this in MATLAB and Simulink. Okay, so this project is basically power quality classification using Neuro-fuzzy logic interference system. So basically what we have to do, we have to first of all classify our power quality in MATLAB, okay? And then we have to use Neuro-fuzzy logic interference system in Simulink for further process. Okay, so here it says like there would be 5 features of power disturbances, okay? Sag, swell, harmonic and flicker. So first of all we need to, you can say, uh, distinguish our power quality in 5 types, okay? And if you come here, it's basically showing us the, you can say, whole process, like how we would do this in MATLAB and Simulink. First of all we have to you can say our we have to first of all classify our voltage swell, voltage sag, harmonic and flicker. Then we have to form you can say input signal. Okay, then we have to use ANFIS, which is, you can say, neuro fuzzy interference system. Okay, so this is basically that thing. And then we have to, you can say, use signal class. This is basically, you can say, proposed flow chart. So first of all what we will do, first of all we would generate the power quality. Okay, like if you go this way, first of all read this thing. In this paper, a power quality classification problem has been raised. A proposed technique using adaptive neurofuzzy has been introduced to classify different type of disturbance events that use fast Fourier transform. Okay, so if you read this thing, it tells us that basically we have to classify different types of disturbance events, and in our case this is our, you can say, electric grid power system. Okay, and you know the electric grid power system has many in the Simulink it has many, you can say, blocks. Okay, we use power block, we use, you can say, uh, bus block. Okay, then we also use some gain blocks. Okay, then we collectively form our sorry and then we collectively form our, you can say, power electric grid system. Okay, and in our case it is also connected to, you can say, by a solar grid, or you can say a wind turbine system, but that's a separate thing. We have to focus on our electric grid system. Okay, and then we have to classify different disturbance types that could occur in that thing, and then we have to use neuro-fuzzy logic interference system for further classification. So if we come in MATLAB, okay, so first of all what we will do, okay, we will first of all give input for our Simulink model. Okay, like this is our Simulink model. Okay, and you can say this is our power supply, this is bed, this is bus, and this is again connected to a, you can, transformer. We can change this power as well. Okay, and then it's connected to the load. If you see the structure of the you can say electric grid system. Okay, like if I have generated some previous projects on this thing as well, if I can show you that. It's a bit slow. So what we do, we have a, you can say, a generator. Okay, that generator is connected to a grid. Okay, and through that grid we calculate how much power we are getting, and there are variations by which we can do this thing in Simulink. So first of all, here we're getting our power supply. Okay, from, you can say, the grid, the power supply is coming, then we are using transformer, and we also using load to calculate like how much power is coming from our that thing. Then we use some like fault and multi-stage fault blocks. Okay, then we use different scopes. Okay, so this you can say uh, this script, okay, this script is connected to the Simulink model. Okay, this Simulink model. Okay, so when we're gonna run both things, it will show you like what is the disturbance in our electric grid system. Okay, and then it will also show you like what is our voltage swell. Okay, like here it was telling us like what is our voltage sag, what is voltage swell, what is voltage flicker, and what are the harmonics. We can change the parameters on x and y axis. Okay, so the last thing is, I'm just giving you an overview of neuro-fuzzy logical system. What we're gonna do, we can do this in multiple ways, but I have chosen, you can say, the more simpler way, we will gonna be using apps. Okay, we're gonna come here and we're gonna type in neuro. Okay, we're gonna come to the Neuro-fuzzy designer. It will take a while. So till then I'll show you the thing. Okay, then what we do, we get our first of all the sine wave, input sine wave. Then we see like here, what's wrong with it? A sag disturbance, swell disturbance. Okay, what is our harmonics in that case? Okay, and what is the transient disturbance? And what is the sag harmonic, sag disturbance, harmonic disturbance? And what is the flicker disturbance? And finally Simulink will show like what is our bus waveform. Okay, the bus waveform is telling us the power is coming from the electrical grid and how that behaves. Okay, if we have the power of 11 kilowatt and we can use that power and supply that into the Simulink thing, then how this instantaneous waveform will behave. Okay, it will show you like it rises for some point, then it comes down, it rises, comes down. Okay, so okay, what the so basically what will happen, I think it's getting slow. So what will happen, you will just come here. Okay, you will type in your Simulink model apps, you will apply Neuro-fuzzy logic. Okay, NEURO, you will open that and then a window will appear that will ask you like on the bottom upload data. Okay, you will select workspace. Okay, you will choose your you can say the plots which you want to use in Neuro-fuzzy logical system, like you want to use T, Y. Okay, just click T. Okay, it's come, it has come. Okay, so it will ask you like load data from workspace. Okay, you will load data. It will then you will like for example, if I want to upload this thing T out, when I will say this thing load data, it will ask us to, you can say input variable name, like I want to use T out. Okay, okay, I don't know what's getting slow. So when you will select like two of your data, for one for x-axis, one for y-axis. Okay, and data needs to have at least two columns. No, that is not. Okay, basically that is not, you can that data T out, we will be using like this thing T and Y. Okay, when we run this thing, we load this data basic, and then we click on this thing, generate FIS. Okay, and it will show us like how our Neuro-fuzzy designer is working over this system. Okay, so that's for now. I've just given you a rough look on overall like how this project is being distributed. So if you feel anything that you don't understand, feel free to ask me. Okay, don't hesitate. Okay.